it the determinant 2, 4 minus 5 minus 1. It is a determinant of second order. And if I call it determinant A, how do you evaluate this determinant A of order 2, 2, 4 minus 5 minus 1? You multiply the elements of the main diagonal, so you will get 2 into minus 1 and minus times the product of the elements on the other diagonal, minus 4, 5 into 4. So you get minus 2 and minus plus 20, so the answer is 18. The value of determinant is 18. Now likewise, for question 2 first part, what is the value of determinant? Say determinant A, multiply the elements on the main diagonal, so cos theta into cos theta, cos square theta minus sin theta and sin theta minus sin theta, so minus sin square theta, that is the product on the other diagonal. So you get cos square theta plus sin square theta, which you know trigonometrically 1. So value of determinant A is 1. Now question 2, second part, you know, if I denote it by A, determinant A, the elements are x square minus x plus 1. The second element of the first row is x minus 1. In the second row you have x plus 1 and x plus 1. How do you expand it? That first you take the product of the elements on the main diagonal, that is x square minus x plus 1 into x plus 1. And then the elements in the other diagonal, this product, so you have x plus 1 into x minus 1. As far as solving is concerned, it's very simple. What are the factors of x cube plus 1? Can you tell me what are the factors of x cube plus 1 or a cube plus b cube? It is a plus b, a square plus b square minus ab. So if you take the product, directly you get x cube plus 1 cube, that is x plus 1. Similarly, the product of x plus 1 into x minus 1 using a plus b into a minus b is a square minus b square, you get x square minus 1. And now just open the bracket, you get x square x cube plus 1 minus x square minus x plus 1, and add them up, you get x cube minus x square and 1 plus 1, 2. So that is the value of determinant, x cube minus x square plus 2. Now the third part. Here A is, you are given a matrix A. Remember matrix 1, 2, 4, 2. And he says, show that twice matrix A, the determinant of 2 times matrix A is 4 times the determinant. So let me first of all find out the value of determinant A here. Determinant A. How do you find the value of determinant A? Elements on the main diagonal to be multiplied. So 1 into 2, 2 minus the product on other diagonal. So you have 2 into 4 minus 8. So the value of determinant A is minus 6, call it 1. And now work out the value of 2 times matrix A. You know, multiplication of a matrix by a scalar. Each element is to be multiplied by 2. So you get 2 into 1, 2, 2 into 2, 4, 4 into 2, 8, and 2 into 2, 4. So what is the value of determinant 2A now? The value of the determinant of 2 times matrix A. Multiply the elements on the main diagonal, 2 for the 8 minus 8 for the 32. So you get 8 minus 32, that is minus 24, which may be written as 4 into negative 6. And you know, from 1, what is the value of determinant A? The value of determinant A is minus 6. So it may be written as 4 times determinant A using 1. So what do we conclude? We conclude that the determinant value of twice matrix A is 4 times the value of determinant A. Now next sum. It is question number 4. In question number 4, you have to prove that 3 times determinant A. 3 times, the determinant of 3 times matrix A is 27 times determinant A. So at least let me work out first of all the value of determinant A. It is a determinant of third order. Can you tell me what will be the most convenient to expand it with respect to any particular row or column? We should expand it with respect to first column because it involves two zeros. So expand with C1. You already know the sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. So here it will be plus one time, that is one time, delete the row and column through 1, you get 1 into 4, that is 4 minus 0, and rest of the two elements of column 1 being 0, you get 0, 0. So it is 1 into 4, that is 4. The value of determinant A is 4, call it 1. And now, because you have to find the value of determinant of 3 time matrix A. So first of all, multiply 3 by 3 to each element of matrix A to get 3A. So that way 3A will be 3, 0, 3, 0, 3, 6 and 0, 0, 12. Let us work out the value of determinant of this matrix 3A. Determinant 3A. Again, it will be convenient to expand it with or along whatever you say C1 because it involves two zeros. So it is 3 times, delete the row and column through 3, there is A11 element, so you left with 3 times the elements on the main diagonal, 3 times 12 minus 0 into 6, so you get 3 into 36 minus 0, so only 36 equal to 108. And this 3 into 108 may be written as 27 times 4. And you know, from 1, the value of determinant A, the value of determinant A is 4. So let me replace this 4 by determinant A. So what do you find? That the value of 3 times, determinant of 3 time matrix A is 27 times determinant A. Determinant of 3A is 27 times determinant A. You may make a note here, please note, that if we are given a matrix, squared matrix A, Aij, of order n, n by n, then the value of Ka, value of determinant K times A. Ka is the product obtained on multiplying each element of matrix A by K, will be K to the power n times determinant A. How do you verify? In the present question, you know, what is the value of K? The value of K is 3. And what is the order of the matrix? N, order of the matrix is 3. So using this formula, what should be the value of determinant K? K to the power n, that is 3 to the power 3. And what is the value of determinant A? That was 4. So it will be 27 times 4. So remember this formula. You may be asked in general that if given is a determinant, given is a matrix of order n, what will be the determinant of Ka? So it will be K times n into determinant A, where n is the order of matrix. Now next sum, we have just to evaluate the value of this determinant, and it is very simple because the second row has already got 2 zeros. So let us expand it. Expand with row 2. Sign convention, you know, plus, minus, plus, minus, plus, minus, plus, minus, plus. So second row will take minus, plus, minus. So in the second row, if I call it determinant A, it is already 0. The second element is also 0. And the third one is minus 1. And here by convention we'll take it minus times. So minus times minus 1 into, delete the row and column through minus 1 now, and you get 3 minus 1 and 3 minus 5. And now evaluate the second order determinant. So here you get minus minus plus 1 times minus 15 and minus minus plus 3. So you get answer as minus 12. Now the second part, question 5, second part, evaluate. You know, it doesn't involve any element as 0, so we can evaluate it expand it with respect to any one row or column. And as I told you, normally we do it with respect to R1. So expand with R1. So it will be 3 times, delete the row and column through 3, you get 3 times determinant 1 minus 2, 3, 1 and determinant and minus 4 times, and as per convention plus minus plus minus plus minus plus minus plus. So for the second element of the second row, it should be negative times. So negative times negative 4, delete the row and column through negative 4 now, and you get 1 negative 2, 1 negative 2 and 2 1. And then the third element is 5, and that will remain plus 5, and delete the row and column through 5. So you get 1 1 2 3. And now it is simple to expand it. It will be 3 times 1 and minus minus, because the product will be minus. So minus minus plus 6, and here minus and minus plus 4 times 1 and minus plus 4, and for the third term 5 times 3 minus 2. So it is 3 times 7 plus 4 times 5 plus 5 times 1, and you get 21 plus 20 and plus 5, that is 46 is the value of given determinant.